Hello, everyone. Thank you for joining the session today. CICD Machine Learning. Today's episode, we are going to talk about model serving using the Flask API. My name is Anthony Sonadi. The last time we talked about DVC, how we can use DVC to build a pipeline. We did that orchestrating a pipeline from stages like from data ingestion or data processing, the parameter search, monitoring, and evaluation. So we did that the last time. This time we are going to be, serving our model using Flask API. Okay, so just imagine that you've finished training the model and you are good with the model's predictions and the result and everything, right? And now you want to expose the model to the public, so you need to uh, serve the model, wrap the model into an API so that people can interact with the model and get predictions, right? So for us to do this, we can do this with so many API frameworks. The one we're going to be using today is Flask API. It's very simple and popular. I mean, easy to implement, right? So I'm going to start by creating start by creating so I'm going to start by creating a file we can use to write the API, right? Call it API as the file. And then I need to make sure that my environment is activated. Okay, and we need to install the Flask itself. I feel like I have it already here, so it's already here. So I've prepared a framework that we can use to build a robust, endpoint or API, right? For your model serving using Flask, right? So I've done this somewhere. I'm just going to bring the code, and then just to make it faster, and then I can explain, what each of those codes are doing, right? Okay. So first of all, we need to start by importing, right, the necessary things that we need to use to build this. So if you check here, I have the Flask. I have to import Flask, import these modules that I'm going to use to write the API. And then I have transformers, we built a robotic model. We fine-tune the robotic model, so I need to bring all this into this file so that we can load the model, load the tokenizer, and all those kind of things, right? And touch, we also have logging. We can use to write our logs, right? And then from data process, I brought this clean text, for this guy, data process, we have this guy clean text. We used to remove the URL, the emoji. So in case the text we're passing to the model in production has those things, so we need to first of all do all those cleaning we need to the model before training. All those cleaning we need to the data before training, using to train the model. So we need to also make sure that on inference, when data is passed to the model, it also goes through the same pipeline of cleaning the inputs and making sure it's put in the best way the model can now use it to do prediction. Okay, so that's why I brought this guy here. So in my framework here, the first thing is to initialize the Flask API, and then the second thing is to set up a log. So we have a log here, and the log is here. Log, we put the log to info, so you can be able to track log all the way down to info level, right? Okay. So the next thing we need to do is to define the model output. I think step 3 is to define the model, just to load the model, right? Step 3 is to load in the model and tokenizer, right? And we need to define the model parts. Sorry, this. And then we need to define device. So we want to be able to um, load the model into the device, if GPU is available, if I mean to the appropriate hardware we want to use to do this inference. If GPU is available, we load the model to the GPU. If it's not available, we load it to the CPU, right? Device. So we say CUDA. That's if it's available. If that is available, we can do that. It's available, we do that. If it's not available, we do CPU, right? So that's what that line does. And then we need to load, we need to load the model now. So we're going to put this into a track block where we do model, this is the model. We load it from pre-train, right? And then passing the model parts, right? The same thing goes to the tokenizer. So we can also define this in a different file, and then import it into this API. So we just have only the API stuff here. So, but I just want to write it here so to let you guys just know, how everything is being done, right? So the tokenizer. So it's initialize these guys. Okay. Okay, so once we do that, we need to make sure that we move the model to evaluate mode, push to evaluate mode for inference, and then move the model to the device that's available, right? Right, that's available. And then we can do exception as E, and then we can say that if that does not happen, if there's an error, we raise a runtime error, and so we can say fail to load, fail to load model optimizer, right? This is it, right? Okay, and we try to just put some log here. Let's say logger that's info here. Loaded the model and tokenizer successfully, right? And then also try to put logger here. Logger that's error. So there was an error. If that does not work, that should be error. Error loading model tokenizer. So just gonna put it's called the error. That's not what is the exception. Okay. So we're gonna load the model here, right? And then we need to define, for human readability, we just want to be able to make sure that the classes, we've trained this model to do sentiment classification for in Igbo language, where we have neutral, positive, and and negative, right? So we need to make sure that we do prediction class marking for human readability. right? And then we can say class mapping. It's going to put that to a dictionary. So we do something like this. Okay. So you just have to make sure that this really represents the way your model is being trained. That's 0 actually represents that's what's it called again? The positive actually represents 0 and neutral represents 1. And then negative represents 2. All right. So you have to make sure that you get that way. 2, 1, 0. Okay. Okay. So for that, the next thing to do is to prepare the inputs. Step 4. So let's say this is step 3. Step 4. So this should be step 5. Inputs. So you need to prepare the inputs the way we did it during training. So that's why we have this guy. We would call this guy to clean the test, right? So I think I've written a function already here. So I'm just gonna call it. I'm just gonna paste it here. So what this function going to do is also help us to prepare the model, the data, the way it will be passed through the model, right? The same thing we did during the uh, model training, right? So we save the cleaning test, just like I mentioned before, this data I imported from this place, right? So we clean the test and then we tokenize the clean test with the max length of 512 here, and then truncate any length that is smaller than that, and then we can return the touch tensors, right? Yeah, just so we return the tokenized input, right? Okay, so the next part is actually to define the endpoint. I mean API endpoint, right? So I'll just says sorry, step 5 or 6. Yeah, API endpoint. So I'm just going to copy it also and paste here. Okay. So this is the API endpoint. So I think I need to put a signature. Update routes. And then we can define the routes. It's predict. Okay. And the method is post method. I believe you guys know about the post, the delete, the get, and the update methods for API. Right. So what I need to do is to explain this guy. So first of all, we try to um, validate our request and make sure our request is in JSON. If it's not in JSON, we return this error, right? And then we get, I mean, we save the data here, and then the data is, the data here, and then from the data we get the test, right? Which is what the user has put, and if there's no test, we return none, right? And then so if the test is not available, so we can tell the user that's invalid input test, right? Field is required. Field is required and must be a string, So, and we return this error code here, 400, right? That's if the user does not input a string to the if the user does not pass in a string to the endpoint, right? And then if that is a string, right, we can save the input here, the test input, and prepare it. Preparing it means that we will pass through, run it through here. There is a function that we wrote here, to clean the test, tokenize it and everything, right? And then we move the data, which is the input test, to the device. So we want to make sure that the data that user passing and the model are on the same device. So if the device available is GPU, all the data and the model should be in the same device. If it's CPU, they should be in the same device. So that's what we're doing here, to move that to the device, right? And then we perform inference, right? So we need to make sure that we need to disable gradients, right? So we say touch.no grades, to disable gradients, to allow, the model to run, more efficiently, and increase the speed, right? So it doesn't need to calculate gradients. So that's how we did that in inference. So we save the model output here, what the model predicts, with the model we pass in the input test. And then we save the prediction here. So the prediction here is going to be like probabilities, based on those classes, the neutral, positive, and the negative, and the negative, right? So which probabilities, the one that is the highest, the lowest, and all those kind of things, right? Yeah. So we these are the predictions, right? And then we save the predicted class here. We take the highest value, the argmax. The highest value is the highest value of the prediction. And then we return the confidence. Confidence score. For I can say probability. Yeah. So how confident is the model in predicting that class as the class is predicted to be? Okay. And then for human readability, we want to make sure that we map the class, to the class labels we initialize, we already mentioned here, right? So that people can see that, oh, this is positive, this is negative, instead of returning the number. Okay, so that's here to get a predicted class. Then if there's no predicted class, if that's not available, it returns unknown, that it doesn't know the class. Okay. So at the end of the day, we return the test to the user, the predicted class, the predicted label, and the confidence score. So this is what is going to the user. And if that goes through, we return okay, and make sure that the API was able to go through with no errors, right? And we wrap that into a Unify object here. This guy is going to help us to convert this dictionary into a JSON, so that's what the user is going to get, right? And then if there's an error, we log the error, and then we log the error, make sure we don't log the error as an error, and then we return the error, an internal error called during prediction, blah blah blah, 500, so kind of thing. So this is just about the function it's about the routes, the predict function, and then wrap it into an API, that users can use to get response from this model. Okay. So the next thing we can do is to run the Flask app, right? Step what? It should be step 6, step 7. Step 7. Okay. So to run the Flask app, thing is something like this. Name is equal to quotes. Yeah. So you can say app just run the host is what 0.000, and we define the ports. Okay. The ports we run into the ports of 5,000 thereabouts, and then say debug is equal to true. So this is still debug mode. Oh, so that's 4. So okay. Okay, so we're just going to try to run this to see how this is gonna work. Okay. So I'm gonna run it on the command line. So right, here is we have some errors here. So the error we have here, runtime error, failed to load the modern tokenizer, provide either the path to look. Okay, we didn't provide it. Okay, so I think the problem here, let's go check the code. 928 something, right? Oh, okay, we have not provided a path to the model. So we have trained the model. I think we saved the model here. Let's see. We saved the model here, fine-tuned. So we copy the paths here. So we run again. See if there's an error we can get. So we still have an error here. Oh, okay, there's an error here. Type error, got an exception. Keyword must be methods. Sorry, I think that should be here. Methods, just S. I need to code there. So again, and see if there's an error again. Okay, so I think this is working now. I just need to uh you know to okay, so I have something here already. So I'm gonna use call to test the API, on my command line. So of course we're making a post request, right? And this is the URL to the API, to the endpoint, and then this is the content, the text that we want to pass into the model. You can see it's in JSON. Sorry, it's in string, right? So we're just going to hit and see the response we're going to get from the API endpoint. Okay, so you can see the confidence score is this. the predicted class is 1, and the prediction label is neutral, and this is the test we'll pass it to the model. So this is how you can do that, and of course, when you deploy this into a server, a cloud-based server, it's actually what you'll get, right? This is just how to, write start your model, wrap it into an API so that people can use it. So if you have a front-end application, they're going to use this URL to consume the API, to interact with the API, yeah. So that's how you can, serve your model, using Flask API. Thank you very much for joining the class. Please don't forget to hit the like button. Don't forget to share my video to your audience, to your friends. Don't forget to share, comments. Thank you once again. See you in the next class. Bye.